Now let's have a look at this first example for half range Fourier. This for the case I purposely make it in terms of sine series. So we're going to consider function f of t equal t square, which is going to be from 0 until pi. And again, so this function over here, this is not a periodic function. Okay, so what we're going to do is first we're going to sketch the function f of t, and then we are going to convert that to a periodic function, which we're going to call as being the f star t. So we're going to sketch the whole function, and we're going to write down the analytical description, and the sketching will be from negative pi until 3 pi. So this is going to be the interval. Right, and after we are done, we have figured out the Fourier series, then only we can find the half range Fourier sine series. So only step number 1 will be different between full range and half range, which is converting your function from f of t to a new function, which we're going to call as f star t. But in terms of the calculation, is going to be exactly the same. So if you have mastered the calculation for full range, you should have no problem for calculation for half range as well. So now let's start with this problem right here. So first of all, so I'm going to sketch the function f of t. So it's going to be from 0 until pi, but later we're going to consider the whole thing, and that is going to be from negative pi to 3 pi. So I'm going to prepare the axis right away. So it's going to be negative pi on this side. So I'm going to have pi, 2 pi, and also 3 pi. Okay, so this is going to be the t-axis. So this is going to be the axis of f star t. Okay, so the function is going to cover, this is going to be the function. So the lowest value is going to be 0, the highest value is going to be pi. So we know that when t is equal 0, my f of t is going to equal 0 as well. And when t is equal pi, so my function f of t is going to equal pi squared. And remember, this is t to the power of 2, which is x squared. So we know how the graph of x squared looks like. Alright, so the thing is that, so for sketching, so if I have a graph of f of t equal t square, so this is how the function looks like. Okay, f of t equal t square. And what happened is that we only have to extract this from 0 until pi. So where's going to be 0? So 0 is going to be here. And pi, if this is going to be my value of pi, so this is going to be a function of pi square. So we only want this shape from 0 until pi only. So that is why when I do the sketching of my function f of t equal t square, so this is how the function looks like. And somewhere over here, so this is going to be pi square. Okay, so that is going to be A. And now I'm going to start doing B. So B, you have to sketch and write the analytical description of f star t. So knowing that this is supposed to be a sine series. And we know that what information do we have if it's a sine series? So if it's a sine series, we know that the function is supposed to be odd. So therefore, when we sketch the function, okay, so I'm going to put over here. So this is going to be a sine series. Okay, so what happened is that your function f star t is supposed to be an odd function. I remember when we have an odd function, we have to reflect that twice on both axes, on the vertical axis and also the horizontal axis. And of course, when I reflect this for the first time, for example, let's say I'm going to do that on the vertical axis first. So that's how it looks like. And when I reflect that again on the vertical axis, so the horizontal axis, so this is how the other half is going to look like. And I'm going to erase this part right there, and I erase too much. And here, so here at the bottom, because they are symmetrical, so this is going to be a value of negative pi square. So that is going to be the case when we have a sine series. So you have to make it into an odd function. Okay, so now that I already have the function, I can straight away write the analytical description. Okay, so if you refer back to the graph, the whole cycle that I've written over here, so it covers from negative pi to pi. So therefore, my function is also going to cover from negative pi to pi. So from negative pi to 0, that is going to be one function. And from 0 until pi, so this is already given in the question that it's going to be a function of t square. So from negative pi to 0, so this is how the line looks like. So this is going to be my function, and we know that this is a graph of t square as well, but now it's going to be concave, what do you call it, concave up, concave down. Okay, and this is going to be the case that you have a negative, and the intersection is still going to be at 0. So that is basically a graph of negative t square. So it's going to be negative t square from negative pi to 0 and t square from 0 until pi. And of course, so here the distance from negative pi to pi, so that will be a distance of 2 pi. So therefore I'm going to write the bit about the period. So f star t is going to equal f star of t plus 2 pi. So that is going to be the function. And actually, like sometimes in the final exam, like the half range is going to be the last question. Before that is going to be the full range. If you don't remember how to write this whole thing right here, how the structures are given to are written in terms of the period and such, you can refer to previous question how it is written. Okay, so make that as your reference so that like you know how to put the period function and so on. Okay, so now that I am done with this, however I'm not done yet, there's something that I missed. So I haven't filled in my graph from negative pi until 3 pi. So from negative pi to pi, there is going to be one cycle, and of course I'm going to have another cycle from pi until 3 pi. So I'm going to have a graph down here and up here as well. So that is going to be, I'm going to have 2 cycles in the complete interval of negative pi until 3 pi. Alright, so now that we have all the information, so we can start doing the calculation. And remember, so you have to make this right because there are certain questions that for which your calculation is going to depend wholly on the function that you have written. Okay, so now for the case of C, I'm going to start doing the calculation. So what happened is that f star t is actually an odd function. So what happened is that a0 and an, they are both going to be 0. So now all you have to do is going to be the calculation for bn. So the formula for bn is going to be 2 over t, the integral from d until d plus t of the function f star t. So it's going to be a sine of n omega t dt. And for this case, what is our omega value? So that is going to be 2 pi over 2 pi because the period value is 2 pi. So I'm going to have 1 as the omega. And I'm going to substitute. So t is going to equal 2 pi. So I'm going to have 2 over 2 pi. So my integral, what is going to be my d and d plus t value? So it's going to be here. I'm going to have it from negative pi until pi. So that is going to be my lower and upper limit. So from negative pi to pi of the function f star t. So sine of nt dt. So the same trick that we used previously. So before we start substituting our f star t, so have a look at the property first. So this is an odd function. Sine is odd as well. When you multiply both of this, so the product of that is going to be an even function. Okay, so that is why I'm going to use the even property. So I will end up having 2 over pi. So my new limit is going to be from 0 until pi. And from 0 until pi, so the function that is going to be involved for this case is going to be t squared. So that's my f star t. So therefore I'm going to substitute here. So I'm going to have t squared sine of nt dt. Right, so now all I have to do is integrate. I'm going to integrate here. So my polynomial is going to be t squared and my trigonometric function is going to be sine of nt. So t squared is going to be 2t, 2 and 0. Sine is going to be negative cos of nt over n, then negative sine of nt over n square, and the last one is going to be positive of cos nt over n cube. Right, so that will be the integration of sine, negative sine, and cos again. And then I'm going to put diagonal arrows, put plus and also minuses. And for this case, I'm going to end up with, I have 3 arrows, so I will end up with 3 terms. And I'm going to start substituting and put them together. So I'm going to have 2 over pi outside. So my first term is going to be negative of t squared. So cos of nt over n. And then I'm going to have plus 2t. So sine of nt over n squared. And the last one is going to be positive of 2. So cos of nt over n cube. And this is going to be evaluated from 0 until t. So where the substitution is going to be done, so here, 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 and here. Okay, so now let's start substituting. So I will end up with 2 over pi. So when I substitute this term it's not t. So how did I end up as t? So this is, my limit is going to be pi, not t. I'm going to substitute in t. Okay, so I'm going to end up for this one is going to be negative pi square. So cos of n pi. So that is going to be negative 1 to the power of n over n. And here when I substitute t equal pi, I'm going to have sine n pi. And I know that sine n pi is going to equal 0. And the last one, I'm going to have a 2. So cos n pi is going to be negative 1 to the power of n over n cubed. And then I'm going to have a minus when I substitute t equals 0. Of course, this is going to equal 0. And this term is also going to equal 0 because of that. And the last one, I'm going to have cos of 0. And cos of 0 is going to be 1. So therefore, I'm going to have plus 2 multiplied by 1. So that is going to be 2 over n cubed. Let me... Okay, so there goes my bracket. Okay, so that will be the outcome. And let me simplify this a little bit. So I'm going to write that this is going to equal 2 over pi. So here I'll end up with negative pi multiplied by negative 1 to the power of n over n. And here I'll have 2 negative 1 to the power of n over n cubed. And the last one is going to be negative 2 over n cubed. And actually, I can multiply each of the term by the 2 over pi outside, for which... so I'll end up with something like this. I'll end up with a negative, for the first term is going to be negative 2 to the negative 1 to the power of n over n. So the pi is going to cancel. But actually this is pi square. So I'm still going to have 1 pi at the top. Okay, let me clean this. So I'm going to have negative 2 pi, so negative 1 to the power of n over n, so that will be the outcome. And this term over here is going to be plus 4, so negative 1 to the power of n over n cubed. And the last term is going to be negative of 4, and that is going to, here is going to be 4 over n cubed pi, so minus 4 over, again, it's going to be n cubed pi. So all I did is I multiplied the 2 over pi with whatever terms that I had in the bracket. Okay, so here what happened is that I'm going to have, this is going to be my Bn, and I'm going to get different cases for the case of n, even, and odd. So let's first have a look at what happened when my n is even. So when my n is even, so here I'll end up with, so negative 1 to the power of n is going to be 1. So I'm going to have negative 2 pi over n. And here I'm going to have 4 minus 4. That is going to be a 0. So I'll end up with negative 2 pi over n. So that is the case when n is even. And when n is odd, what happened is that, so I'll have, this is going to be negative 1. I'll end up with positive 2 pi over n. So this is going to be negative 4. So that is going to be negative 8 over n cubed pi. So these two terms over here, you can actually put them together. You can write this as 4 negative 1 to the power of n minus 4 over n cubed pi, because the denominator is the same. So when this is equal 1, of course, it's going to be 0. So what happened, this is what happened for the case of even. And for the case of odd, it's going to be negative 4 minus 4, which is going to be negative of 8 over n cubed pi. Okay, so now I'm going to put it together according to this Fourier series. So my function f star t is going to equal sum from n equal 1 to infinity of bn sine of n omega t. Okay, so we have different cases for odd and even. So for the case of even, I'm going to have sum from n equal, so let's put as n even first. I'm going to put n even first. So it's going to be, I can put the negative outside. I'll end up with 2 pi over n. So sine of nt dt. And for the case of odd, so I'm going to end up with 2 pi over n. So minus 8 over n cubed pi. And it's going to be sine of nt dt. So this is going to be the case when n is odd. Okay, what happened is, okay, for the one that is even, I'll end up with negative. So whatever is not related to n, I'm going to pull that out. So I'm referring to this 2 right there. Sorry, to the 2 pi. So those two, they are not related to. So let me pull that out. So those two are not related to n. So I'm going to write that as negative sum negative 2 pi. So sum from n equal 1 to infinity. So that is going to be sine. So there goes my n. So I'm going to highlight everywhere there is n that I'm going to change. I have n at the top and n at the bottom as well, because this is going to be for the case of even. So I'm going to have sine of 2 nt, and that is going to be over 2n. And for the case of odd, I'm going to have plus sum from n equal 1 to infinity again. So I can actually put the 2 pi outside. So I'm referring to the first term first. I'm going to expand this as two different terms. And for the first term first, I'm going to have a sine of 2n minus 1t, and that is going to be over 2n minus 1. And the third term is going to be negative. So I'm going to have 8 over pi. So I'm going to have sum from n equal 1 to infinity. So terms which are going to be the n, I'm going to have n here and n at the bottom as well. So that is going to be translated to sine of 2n minus 1t, and that is going to be over 2n minus 1 cubed. So that will be the outcome, and that's it. Okay, so if you have like two terms like this, so what you can do is you can separate them, or you can actually leave it like this as well. So just change this to be in terms of 2n minus 1 and also 2n minus 1. So that is fine as well. All right, so that will be the end of the calculation.